Professor Daniel Chua. I'm a director of the Faith and Global Engagement here at HKU. Thank you so much for coming. Now, Now, I'm sure there'll be many questions tonight because we're dealing here with a very big topic, with a big bang and a big God in this big auditorium, and there'll be many big names in the lecture like Stephen Hawking and Albert Einstein and Roger Penrose. So I expect there to be many big, deep, and difficult questions. So I'm delighted that we have a big name of our own here this evening. Professor William Lane Craig. He's a preeminent philosopher of religion, and he's based at the Talbot School of Theology and the Houston Baptist University. He's a very well-known and brilliant debater. He sparred with many of the world's leading atheists, and I think it's fair to say that many of those atheists leave the debate feeling rather bruised and battered by the end of it. He's a very strong advocate of the reasonableness of the Christian faith, that it should stand to the test of reason and is in itself also reasonable. With more than 30 books and 200 articles under his belt, I think you should feel more than free to ask as many difficult questions as you like to him this evening. Ladies and gentlemen, please welcome Professor William Lane Craig.
Well, thank you very much. In the award-winning movie, The Theory of Everything, Stephen Hawking introduces himself to his wife-to-be, Jane, as a student of cosmology. When Jane asks what that is, he replies, "It's a kind of religion for atheists." That remark is both provocative and revealing. Cosmology is obviously not literally a religion. It's a branch of astrophysics which studies the large-scale structure of the universe. But if one is a naturalist, that is to say, someone who believes that all that exists is space-time and its contents, then in a sense, someone who studies the universe is studying the ultimate reality. This is the same project in which the theologian is engaged, except that for the theologian, the ultimate reality is God, not the universe. The theologian has a wider, more encompassing view of reality than the naturalist, for he believes in a reality which transcends the universe. The universe is a subordinate reality which is created by God. For cosmologists who are theists, such as George Ellis, perhaps the world's greatest living cosmologist, who is also portrayed in the movie, cosmology is therefore not a kind of religion, but simply the scientific study of a subordinate reality. But for someone who is a naturalist, it's easy to see how cosmology could become quasi-religious. Now, cosmology is divided into two sub-disciplines, which once again have intriguing parallels in theology. The first sub-discipline is cosmogony, which is the study of the universe's origin. Parallel to this is the theological locus or category or doctrine of creation, particularly creatio originans, or originating creation. Christian theology holds that God created the universe from nothing a finite time ago. Therefore, the universe is not eternal in the past, but had a beginning. The second subdiscipline of cosmology is eschatology, which is the study of the future fate of the universe. Those of you who are familiar with theology will immediately recognize that this term is actually borrowed from theology. For the theological locus or doctrine of the last things is called eschatology. Once again, Theological eschatology has a wider scope than physical eschatology. For while physical eschatology studies the future fate of the universe given present conditions and the laws of nature, theological eschatology also comprises broader themes, such as the state of the soul after death, the resurrection, the new heavens and the new earth, and heaven and hell. Once again, we can see how the naturalistic cosmologist studying cosmogony and physical eschatology might think of himself as engaged in a sort of religious pursuit. While physical eschatology makes a brief appearance in the movie, The Theory of Everything, it is cosmogony that dominates. The film focuses on two cosmogonic theories which Hawking has defended. The first being the standard Big Bang model based on the general theory of relativity, and the second being the so-called no-boundary proposal, which Hawking developed in collaboration with James Hartle of the University of California, Santa Barbara, based on the incorporation of quantum physics into the standard model to yield a quantum theory of gravity. The film explores the alleged theological implications of these two theories. So that we might better understand these alleged implications, let me say a bit about these two approaches to cosmogony. First, the standard general relativistic model. Prior to the 1920s, scientists had always assumed that the universe as a whole was stationary and eternal. Tremors of the impending earthquake that would topple this traditional cosmology were first felt in 1917, when Albert Einstein made a cosmological application of his newly discovered gravitational theory, the general theory of relativity. To his chagrin, Einstein found that general relativity would not permit an eternal, static universe unless he fudged the equations in order to offset the gravitational effect of matter. During the 1920s, the Russian mathematician Alexander Friedmann and the Belgian astronomer Georges Lemaitre decided to take Einstein's equations at face value, and as a result, they came up independently with expanding models of the universe. In 1929, the American astronomer Edwin Hubble, through tireless observations at Mount Wilson Observatory, made a startling discovery which verified Friedmann and Lemaitre's theory. He found that the light from distant galaxies appeared to be redder than expected. This red shift in the light was most plausibly explained as due to the stretching of the light waves as the galaxies are moving away from us. Wherever Hubble turned his telescope in the night sky, he observed this same red shift in the light from the distant galaxies. It appeared that we are at the center of a cosmic explosion, and all of the other galaxies are flying away from us at fantastic speeds. Now, according to the Friedmann-Lemaitre model, we're not really at the center of the universe. Rather, an observer in any galaxy will look out and see the other galaxies moving away from him. This is because, according to the theory, it is really space itself which is expanding. The galaxies are actually at rest in space, but they recede from one another as space itself expands. The Friedmann-Lemaitre model eventually came to be known as the Big Bang theory. But that name can be misleading. Thinking of the expansion of the universe as a sort of explosion could mislead us into thinking that the galaxies are moving out into a pre-existing empty space from a central point. That would be a complete misunderstanding of the model. The theory is much more radical than that. As you trace the expansion of space back in time, everything gets closer and closer together. Eventually, the distance between any 2 points in space becomes zero. You can't get any closer than that. So at that point, you've reached the boundary of space and time. Space and time cannot be extended any further back than that. It's literally the beginning of space and time. To get a picture of this, we can portray our three-dimensional space as a two-dimensional disk, which shrinks as you go back in time. Eventually, the distance between any 2 points in space becomes zero. So, space-time can be represented geometrically as a cone. What's significant about that is that while a cone can be extended indefinitely in one direction, it has a boundary point in the other direction. Because this direction represents time and the boundary point lies in the past, the model implies that past time is finite and had a beginning. Because space-time is the arena in which all matter and energy exist, the beginning of space-time is also the beginning of all matter and energy. It's the beginning of the universe. Notice that there's simply nothing prior to the initial boundary of space-time. Let's not, however, be misled by words. When cosmologists say there's nothing prior to the initial singularity, they do not mean that there is some state of affairs prior to it, and that is a state of nothingness. That would be to treat nothing as though it were something. Rather, they mean that at that boundary point, it is false that there is something prior to this point. The standard Big Bang model thus predicts an absolute beginning of the universe. In the movie, the standard model is described in the following exchange between Hawking and Jane. If Einstein is right, if general relativity is correct, then the universe is expanding, yes? Yes. So, if you reverse time, the universe would get smaller. All right? So, what if I reverse the process all the way back to see what happened at the beginning of time itself? The beginning of time itself? The universe getting smaller and smaller, denser and denser, hotter and hotter as we wind back the clock. Keep winding. You've got to get back to the beginning of time. Keep winding until you get a space-time singularity. The standard model thus predicted an initial singularity. There were, however, suspicions that since the real universe is not perfectly similar to Friedman and Lemaitre's ideal model, their prediction of a singular beginning to the universe would ultimately fail. Perhaps the distribution of matter and energy in the real universe is not homogeneous enough for the universe to shrink down to a singularity. In 1970, however, Hawking, in collaboration with Roger Penrose, proved that the assumption of ideal homogeneity was irrelevant. The Hawking-Penrose singularity theorems showed that so long as the universe is governed by general relativity, our past must include an initial singularity. Now, such a conclusion is profoundly disturbing for anyone who ponders it, for the question cannot be suppressed. Why did the universe come into being? Sir Arthur Eddington, contemplating the beginning of the universe, opined that the expansion of the universe was so preposterous and incredible that, and I quote, "I feel almost an indignation that anyone should believe in it, except myself." He finally felt forced to conclude, "The beginning seems to present insuperable difficulties unless we agree to look on it as frankly supernatural." In a scene deleted from the final cut of the movie, Jane and Hawking reflect on the implications of the Hawking-Penrose singularity theorems. "This is amazing. This is poetry. No, it's black hole theory. Time began at a certain point. There was a moment of creation. Yes, this is God's work. I think you'll find the equations are mine. But, good point." The standard Big Bang model thus predicts an absolute beginning of the universe. If this model is correct, then we have amazing scientific confirmation of the theological doctrine of creation out of nothing. So, is the standard model correct? Or more importantly, is it correct in predicting a beginning of the universe? Despite its empirical confirmation, the standard Big Bang model will need to be modified in various ways. The model is based, as we've seen, on Einstein's general theory of relativity. But Einstein's theory breaks down when space is shrunk down to subatomic proportions. We'll need to introduce quantum physics at that point, and no one is sure how this is to be done. The second cosmogonic model mentioned in the film is just such an attempt to marry quantum physics to general relativity to craft a quantum theory of gravity that will enable us to describe the early universe. The so-called no-boundary proposal developed by Stephen Hawking in collaboration with James Hartle, who oddly enough is never mentioned in the film, is known as the Hartle-Hawking model. The Hartle-Hawking model eliminates the initial singularity by transforming the conical geometry of classical space-time into a smooth, curved geometry having no edge, so that space-time resembles a badminton shuttlecock. This is accomplished by the introduction of imaginary numbers, like the square root of -1 for the time variable in Einstein's gravitational equations, which effectively eliminates the singularity. The laws of physics do not break down at any point, allowing a complete description of space-time. In his best-selling popularization of his theory, A Brief History of Time, Hawking reveals an explicitly theological side to his nature. He concedes that on the standard model, one could legitimately identify the Big Bang singularity as the instant at which God created the universe. Indeed, he thinks that a number of attempts to avoid the Big Bang were probably motivated by a feeling that a beginning of time smacks of divine intervention. He sees his new model as preferable to the standard model because there would be no edge of space-time at which one would have to appeal to God or some new law. Hawking sees profound theological implications in the new model. He writes, "The idea that space and time may form a closed surface without boundary has profound implications for the role of God in the affairs of the universe. So long as the universe had a beginning, we could suppose it had a creator. But if the universe is really completely self-contained, having no boundary or edge, it would have neither beginning nor end. What place, then, for a creator?" Hawking does not deny the existence of God, but he does think his model eliminates the need for a creator of the universe. In the movie, the theological implications of the Hartle-Hawking model are raised in a conversation between Jane, Stephen, and their friend Jonathan. Stephen's done a U-turn. The big new idea is that the universe has no boundaries at all. No boundaries, no beginning. Oh, no God. I see. I thought that you'd prove the universe had a beginning and thus a need for a creator. My mistake. No, mine. Stephen is looking for a single theory that explains all the forces in the universe. Therefore, God must die. Why must God die? I don't see. The two great pillars of physics are quantum theory, the laws that govern the very small, particles, electrons, and so on, and general relativity. Ah, yes, Einstein. Einstein's theory, the laws that govern the very large, planets and such. But quantum and relativity, don't tell me, they're different. They don't remotely play by the same rules. If the world were all potatoes, then easy, you could trace a precise beginning, as Stephen once did, a moment of creation. Hallelujah, God lives. But if you incorporate peas into the menu, then it all goes a little haywire. This all becomes a godless mess. Oh dear. God is back on the endangered species list. Well, I expect he'll cope. As Jonathan rightly discerned, the theological implications which Hawking seeks to draw from his model are highly suspect. There's no reason at all why God could not have created a universe described by the Hartle-Hawking model. When I spoke with James Hartle in his office at UCSB, he saw absolutely no theological implications in the model. Indeed, by positing a finite, if imaginary, time on a closed surface prior to the Planck time, rather than an infinite time on an open surface, such a model actually seems to support, rather than undercut, the fact that time and the universe had a beginning. Such a theory, if successful, would enable us to model the beginning of the universe without an initial singularity involving infinite density, temperature, pressure, and so on. But, as physicist John Barrow of Cambridge University points out, this type of quantum universe has not always existed. It comes into being, just as the classical cosmologies could. But it does not start at a Big Bang where physical quantities are infinite. Barrow points out that such models are often described as giving a picture of creation out of nothing. The only caveat being that in this case there is no definite point of creation. Hawking's crucial misstep is his assumption that having a beginning entails having a beginning point. Ancient Greek paradoxes of starting and stopping have long since taught us otherwise. Imagine that a cannonball has a last instant at which it is at rest before being fired from the gun. In such a case, there is no point at which the cannonball first begins to move. For at any point after its initial or final instant of rest, there will be a prior instant at which it was already in motion ad infinitum. Yet no one would say that the cannonball does not have a finite trajectory and a cause of its beginning to move. Having a beginning does not imply having a beginning point. Time begins to exist just in case for any finite temporal interval you choose, there are only a finite number of equal temporal intervals earlier than that. That condition is fulfilled for the Hartle-Hawking model as well as for the Standard Model. Moreover, it's far from clear that on any realistic interpretation of the Hartle-Hawking model, it does not in fact have a beginning point. By using the mathematical artifice of imaginary time, Hawking is able to redescribe the universe in such a way that it has no initial singularity. Hawking admits, and I quote, "Only if we could picture the universe in terms of imaginary time would there be no singularities. When one goes back to the real time in which we live, however, there will still appear to be singularities." Hawking's model is thus a way of redescribing a universe with a singular beginning point in such a way that that singularity is transformed away. But it is the same universe with a beginning that is being described. Thus, quantum gravity models, like the Standard Model, imply the beginning of the universe. In his later book, The Grand Design, co-authored with Leonard Mlodinow, Hawking himself seems to endorse this interpretation of the model. They write, "Suppose the beginning of the universe was like the South Pole of the Earth, with degrees of latitude playing the role of time. As one moves north, the circles of constant latitude representing the size of the universe would expand. The universe would start as a point at the South Pole, but the South Pole is much like any other point. To ask what happened before the beginning of the universe would become a meaningless question, since there is nothing south of the South Pole. In this picture, space-time has no boundary. The same laws of nature hold at the South Pole as at any other place." This passage is fascinating because it represents a rather different interpretation of the model than what we had in A Brief History of Time. Let me explain. In his model, Hawking employs imaginary numbers, like the square root of -1, for the time variable in his equations in order to get rid of the initial cosmological singularity, which is the boundary of space-time in the standard Big Bang model. The initial segment of space-time, instead of terminating in a point like a cone, is rounded off like a badminton shuttlecock. The south pole of this rounded off surface is like any other point on that surface. Hence the idea that there is no boundary. Since imaginary time behaves like a dimension of space, Hawking interpreted his no-boundary universe to just be. But in the grand design, the South Pole is interpreted to represent the beginning point to both time and the universe. Hawking allows the circles of latitude to play the role of time, which has a beginning point at the South Pole. When Hawking speaks of the problem of time having a beginning, what he means is the age-old objection to the universe having a beginning, an objection which his model removes. So, what is that age-old objection? That objection, he says, is the question, what happened before the beginning of the universe? Hawking is right that this question is meaningless on his model. But what he fails to mention is that the question is equally meaningless on the standard Big Bang model, since there is nothing prior to the initial cosmological singularity. On either model, the universe has an absolute temporal beginning, so that it is meaningless to ask what happened before. Rather, the real question is, why did the universe begin to exist? The Hartle-Hawking model doesn't address that question. How could it? Physics only begins at the South Pole in the model. There is no physics of non-being. Moreover, there isn't anything in the model that implies that that point came to be without a cause. Indeed, the idea that being could arise without a cause from non-being seems metaphysically absurd. Thus, both the Standard Model and the Hartle-Hawking quantum gravity model are united in predicting the finitude of the past and the beginning of the universe. And Hawking's inferences about the theological implications of the model are based on philosophical mistakes. It's sad that so gifted a scientist should have been misled by such philosophical missteps. Both models are perfectly in accord with the Judeo-Christian doctrine of creation out of nothing. I mentioned that physical eschatology makes only scant appearance in the film, The Theory of Everything. It comes only in the penultimate, poignant scene of the movie. Hawking is asked, "You have said that you do not believe in God. Do you have a philosophy of life that helps you?" He answers by appealing to the religion of cosmology. He says, "It is clear that we are just an advanced breed of primates on a minor planet, orbiting around a very average star in the outer suburb of one among 100 billion galaxies. But ever since the dawn of civilization, people have craved for an understanding of the underlying order of the world. There ought to be something very special about the boundary conditions of the universe. And what can be more special than that there is no boundary? And there should be no boundary to human endeavor. We are all different. However bad life may seem, there is always something you can do and succeed at. While there is life, there is hope." Yes, applause for this remarkable man's courage and perseverance in the face of almost insuperable obstacles. But even if it were true that where there is life, there is hope, the lesson of physical eschatology is that absent God, there will someday be no life, and hence no hope. Already in the 19th century, scientists realized that the application of the second law of thermodynamics to the universe as a whole implied a grim eschatological conclusion. Given sufficient time, the universe will eventually suffer heat death. Yale University astronomer Beatrice Tinsley described the fate of an expanding universe. If the universe has a low density, its death will be cold. It will expand forever at a slower and slower rate. Galaxies will turn all of their gas into stars, and the stars will burn out. Our own sun will become a cold, dead remnant, floating among the corpses of other stars in an increasingly isolated Milky Way. Elementary particle physics suggests that thereafter protons will decay into electrons and positrons, so that space will be filled with a rarefied gas so thin that the distance between an electron and a positron will be about the size of the present galaxy. Eventually, all black holes will completely evaporate, and all of the matter in the ever-expanding universe will be reduced to a thin gas of elementary particles and radiation. There is no hope of a reversal of this descent into oblivion. The universe will inevitably become increasingly cold, dark, dilute, and dead. Reflection on this eschatological conclusion has led some philosophers to question the meaning of life itself. In a famous passage, the British philosopher Bertrand Russell lamented that man is the product of causes which had no provision of the end they were achieving, that his origin, his growth, his hopes and fears, his loves and his beliefs are but the outcome of accidental collocations of atoms, that no fire, no heroism, no intensity of thought and feeling can preserve an individual life beyond the grave, that all the labors of all the ages, all the devotion, all the inspiration, all the noonday brightness of human genius are destined to extinction in the vast death of the solar system, and that the whole temple of man's achievement must inevitably be buried beneath the debris of a universe in ruins. All these things, if not quite beyond dispute, are yet so nearly certain that no philosophy which rejects them can hope to stand. Only within the scaffolding of these truths, only on the firm foundation of unyielding despair, can the soul's habitation henceforth be safely built. Russell's keen philosophical mind saw more clearly than Hawking the correct implications of a godless cosmos. Russell, however, was unaware of the evidence for a beginning of the universe, and thus of the need of a creator of the cosmos. When asked to explain the existence of the universe, Russell replied, "The universe is just there, and that's all." This response is understandable on a pre-Einsteinian view of an eternal universe, but it becomes inept when confronted with the fact of the universe's temporal beginning. Such a beginning points beyond the universe to its ground in a transcendent creator. If such a creator does exist, he provides the best hope of deliverance from the grim implications of physical eschatology.
Thank you, Professor Craig, for taking us on at warp speed to the beginning of time and the theory of everything. We now have a time for questions, and some of you, of course, have been very busy typing away already. Just to remind you to go to slido.com, and bang is the code word. And then you just join, type in your questions, and don't forget to like them. So, shall we have the questions? Let's see what we have up here. This is in order of likes. So, the first one. The Bible says God created the earth in 7 days. How does the Big Bang Theory fit into this?
The Big Bang Theory would be incompatible with a literalistic interpretation of Genesis chapter 1, an interpretation that takes the days to be consecutive 24-hour periods of time. However, since the time of the church fathers, such as Augustine, up until the present century, most biblical scholars don't adopt that sort of literalistic interpretation of the opening chapter of Genesis. And I say that not on the basis of modern science, but on the basis of the text itself. There are indications in the text itself that the author didn't intend this to be taken in a sort of wooden literalistic way. And so someone like St. Augustine, for example, knew nothing of modern cosmology or geology, but didn't take this in a literalistic way. And I think that that is correct. I would say that there are many different non-literal ways of construing Genesis 1 that are open to biblically faithful Christians today and that are wholly consistent and consonant with the data of modern cosmology.
So do you want to fit that sort of story into that theory at all, or you just say it's poetic kind of
okay,
thought?
now this is a good question, if I understood your question. You asked, do I want to fit in, right, that
Yes.
cosmology into the Genesis story? And I want to say emphatically no. This is a hermeneutic called concordism, where you try to read the findings of modern science back into these ancient texts. And I think textual scholars and interpreters of literature will say this is an illegitimate hermeneutic. That is, say, theory of interpretation. This is the sort of interpretation that tries to find hints of, say, modern television in the Bible, tries to read modern science back into these narratives. And that's not the way to read ancient literature. You put yourself within the horizon or the shoes of the original ancient author himself and ask, how would he and his audience for whom he wrote understand this? And while I think that the narrative, as I said, is compatible with modern science, it's a mistake hermeneutically to try to read modern science back into it. And so I think we need to let these documents stand on their own and interpret them using the standard hermeneutical tools for reading ancient literature.
Okay, let's move to the second question. Multiverse. Okay, so doesn't the multiverse theory take care of the cosmic beginning argument?
The talk tonight was very limited in its scope. I was addressing only the two models that are featured in the movie The Theory of Everything, on the life of Stephen Hawking and his wife Jane. I didn't attempt to address other versions. If you're interested in that, you can look at my lectures on the existence of God and the beginning of the universe, or if you want to read something, take a look at the article in the Blackwell Companion to Natural Theology, which I co-authored with the physicist James Sinclair, in which we go through the wide range of cosmological models that are available today, which attempt to avert a beginning of the universe, and show why these models that do not feature a beginning are untenable. Now, specifically with regard to the multiverse models, so long as the multiverse obeys what is called the Borg-Guth-Vilenkin theorem, which says that any universe which is in a state of cosmic expansion on average throughout its history, then even the multiverse itself has only a finite past and cannot be infinite. And it's for that reason that Vilenkin, Borg, and Guth developed this theory against past eternal inflationary models of the universe, which featured a multiverse of worlds, which are bubbles of true vacuum in an expanding ocean of false vacuum. And they showed that this inflationary multiverse cannot be infinite in the past, but must itself have a beginning. In 2012, to draw this story back to Stephen Hawking again, there was a celebration at Cambridge University of Stephen Hawking's 70th birthday. And at that conference, Alexander Vilenkin read a paper entitled "Did the Universe Have a Beginning?", in which he surveys contemporary cosmology and the various models. And he concludes none of these scenarios can actually be past eternal. And this lecture is available on YouTube. If you will look for that conference and Vilenkin's name, title of his lecture, "Did the Universe Have a Beginning?" And this is a very accessible lecture, which the layperson can understand, and will deal with some of these other models that try to feature multiverse scenarios.
Since you mentioned Vilenkin, maybe we should just pop down to the question that says, how would you respond to the idea recently voiced by Alexander Vilenkin, among others, that the universe itself is eternal?
Yes, I think that the person here is mistaken. I notice he misspelled Vilenkin. In fact, Vilenkin published an article just in the fall of 2015 called "Did the Universe Have a Beginning?" And it's in an online magazine, and in it he says exactly the same thing. The universe probably began to exist. This is where the evidence points. And then he tries to explain how you can get a universe from nothing. So I think that the questioner is simply misinformed. I wish I could give from memory the reference to the online magazine, but again, if you were to Google Alexander Vilenkin, "Did the Universe Have a Beginning?" It appeared in the fall of 2015, and it is again a very good semi-popular article on this question.
Thank you. So let's move on to the question that goes, if one can accept that God has no beginning or end, is it possible to make the same assumption of the universe, implying that it needs not be created?
There are two ways in which something can be without beginning or end. One way would be to endure through infinite time, from infinite past to the infinite future. Then you would be without beginning or end. The other way to be without beginning or end is to transcend time altogether, not to exist in time. Something that does not exist in the dimension of time has neither beginning nor end. So when theologians say that God is eternal, they have typically meant that God is timeless. He transcends time. And this is implied by time having a beginning. If time and space had a beginning at a point in the finite past, then the cause of time must be beyond time, must be timeless. So God doesn't exist before the Big Bang. There is no such time. Rather, he exists beyond the Big Bang in the sense that he transcends time and brings space and time into existence. So, God's existing timelessly doesn't confront the same sort of absurdities that are involved in the idea of an infinite past.
Something rather different now. After seeing AlphaGo's performances, I think that's the computer program, do you think artificial intelligence will put an end to human beings in the near future?
This is not an area on which I'm qualified to have an opinion. My colleague J.P. Moreland works in philosophy of mind, and I would refer folks to his work. You can find that on Amazon.com. He has quite a number of books like Body and Soul on philosophy of mind, where I expect he would address artificial intelligence, but this isn't my area.
Okay, we'll move on then. So how should we then read Genesis in the Bible? What's the best way of doing this?
I'm not sure. In my lectures on our website, reasonablefaith.org, I have a series, a class, as it were, in Christian doctrine, where we go through the whole body systematically of Christian doctrine. And one of these is called Doctrine of Creation. And in the lectures that you will find there, I survey about 8 different interpretations of Genesis 1, which are defended today by biblically faithful Christians. And I try to assess as honestly as I can both their strengths and their weaknesses. And I'm still undecided. I do not carry a brief for any particular view. I think some of them are more unlikely than others, and I'm more critical of them. But others, I think, represent open possibilities. And so folks could look at those Defenders lectures in Defenders Series 2, Doctrine of Creation. But the short answer is, I'm still searching, I'm still reading, and open-minded about this.
The next question, but why must we have a God? So you've sort of said we must have a God because there's a beginning.
I guess that depends on what you mean by a God. I haven't tried to, well, perhaps I have. In the argument tonight, I've tried to show that there's no incompatibility between these two models defended by Hawking and the existence of a creator of the universe. But you could go farther and say that the beginning of the universe actually implies the existence of a creator of the universe. And when you analyze what properties such a being must have, quite a number of theologically striking properties will come out of such an analysis. You find that such a being must be uncaused, beginningless, timeless, spaceless, immaterial, changeless, enormously powerful, and I would also argue personal. So that what this gets you to is a beginningless, changeless, timeless, spaceless, immaterial, enormously powerful, personal creator of the universe. And I think that's sufficient to warrant the label God.
But could you imagine the same theory of the universe and just posit no God?
No, because, as I say, there needs to be a cause for why the universe came into being. To say that something can come into being from nothing without a cause, when you think about it, that's worse than magic. Right? I mean, when the magician pulls a rabbit out of the hat, at least you've got the magician. But to say that the universe just appeared at some point in the past with no cause whatsoever is literally worse than magic. So those of us, I think, who believe that there must be a cause of the universe coming into being, I think cannot be accused of being unreasonable, because I think there's nothing more unreasonable than adopting an alternative that is literally worse than magic, that the universe came into being uncaused from nothing. And once you've got a cause, then, as I say, these properties will fall out that will give you a timeless, beginningless, spaceless, immaterial, changeless, enormously powerful, personal creator of the universe.
Well, maybe the next question sort of follows on from this a little bit. If there is a creator, did the chicken come before the egg? And if so, is there a creator of the creator? Isn't this just an infinite loop?
Right. If the egg is the universe and the chicken represents God, then the chicken comes before the egg. Now, not in a temporal before. Remember, I've already said that God is not temporally prior to the universe, but before in a causal sense. God is causally prior, not temporally prior to the universe. And then there simply is nothing causally prior to God. God is a timeless, spaceless being that simply exists outside of time and space, and therefore there is no cause. It's a first uncaused cause, as Aristotle put it.
We have a question that's just written on a
and
piece
so
of
no
paper
loop,
here.
obviously.
So we have a question here that's written on a piece of paper, but maybe sort of relates to this. And the question is, okay, so you posit that there has to be a God, given this theory, but why does it have to be a Christian God?
Okay.
It's not up there.
Or
It's
Muslim
on
or Jewish,
it's on this piece
right?
of paper here.
Yeah, or Muslim or Jewish.
Yes,
it's it.
exactly. Yes.
And this is a great question. I've described the kind of being which is implied by this argument. Now, that is the sort of creator, the sort of being in which the great monotheistic faiths believe. Judaism, Islam, Christianity. That already narrows down the scope of the world's religions to these great monotheistic faiths, because these other pantheistic or polytheistic or atheistic religions don't have a timeless, spaceless, enormously powerful, timeless, personal creator of the universe. So in fact, this argument really narrows down the scope of the world's religions to these great monotheistic religions. And then beyond that, that's a different topic that I haven't tried to address tonight. I think beyond that, it's going to depend on what you think of the man Jesus of Nazareth, whether you think he was a mere prophet, a holy man, or you think he was something more, as Christians believe. That will then probably move you in the direction of one of these types of monotheisms. But we've already narrowed down the field to the world's great monotheistic faiths.
But couldn't you call that, whatever that God at the beginning is, chance or something like that, another sort of term that would not have the implication of
I knew somebody once who was named Chance. So you can call him whatever you want. I mean, you can call him Robert or Chung. I mean, it doesn't matter what you call him. The point is that philosophically, what you need is a beginningless, timeless, spaceless, immaterial, enormously powerful, personal cause that brought the universe into being. And it doesn't matter what you call it. In fact, If you don't want to call it God, that's fine with me, but you nevertheless get that sort of personal creator of the universe if this argument is sound. Let me just summarize this argument very simply for you. Premise one, if the universe began to exist, then the universe has a transcendent cause. 2, the universe began to exist. 3, therefore the universe has a transcendent cause. That's a logically valid argument. The only question is the truth of the two premises. Are those two premises more plausibly true or false? And I think that the evidence is very strongly that those two premises are more plausibly true than false, and that therefore the conclusion follows that there is a transcendent cause of the universe.
Perhaps what's not so clear is your claim that it's a personal God, maybe, in this.
Yes, you're entirely right. I didn't go into that tonight. I mean, but I do in my written work and in my other lectures on this, I give 3 arguments as to why this uncaused first cause must be personal. So that's in the written work. You can find it at the website, reasonablefaith.org. But again, given my limited goals this evening, I simply wanted to show the compatibility of the Christian doctrine of creation with the 2 models that Hawking has defended and that are featured in this movie. But I certainly do deal with the arguments for the personhood of the Creator in my written work and on the other.
Need to go elsewhere to find that answer.
Yes.
So the next question, I think, is to do with a reasonable faith. The Bible says that blessed are those who have not seen and yet have believed. So why then the need to show religion is not at odds with science?
What did Jesus mean when he says that? That is a saying that appears in one of the resurrection appearance stories where so-called doubting Thomas says that I will not believe what his other disciples have told him, that they have seen the Lord. He says, I'm not going to believe unless I can put my finger into the wounds on his hands and my hand into the wound on his side. And Jesus then appears to the 12, including Thomas, in the upper room. And it's very interesting. Thomas does not, in fact, touch his wounds or put his hand in his side. Thomas just falls to the floor and says, my Lord and my God, when he sees him. And it's at that point that Jesus said to him, Thomas, do you now believe because you have seen? Blessed are those who believe but have not seen. And what Jesus is indicting Thomas for is that he failed to believe the apostolic testimony to the resurrection of Jesus. He was skeptical of what these disciples had testified to, what they had seen and heard. And in the same way, the author of the Gospel of John is saying to us later readers, we too need to believe the apostolic testimony and shouldn't demand that Jesus appear to us in our bedroom at night, but rather we should believe what these original apostles have testified to. And I think, now this is a totally different topic, I think that historically this testimony is extremely credible. That we have very good historical grounds for thinking that the tomb was found empty, as the narratives say, that these disciples did experience resurrection appearances of Jesus that changed their lives. And so I do believe the apostolic testimony, and I think that's what Jesus is saying. He's not asking you to put your brains on the shelf and believe something that is contrary to science and to the evidence. He's saying, believe the apostolic witness to my resurrection, rather than demanding that Jesus appear to every person in every generation in the ages to come.
I think the question also is asking whether it's really compatible. Well, do you really need to do this thing with faith and science? Aren't they sort of separate modes of knowledge? And it kind of, mixes things together.
I would refer folks to a dialogue that I had yesterday at the Polytechnic with a Buddhist faculty professor on science and religion. And I gave a Christian perspective on science and religion, and she gave a Buddhist perspective on science and religion. And what I emphasized is that Christianity and science have areas of overlap where they speak to the same issue. And we've seen one tonight. The notion that the universe had a beginning, that the universe is not eternal. That view was rejected by ancient Greek materialism and modern atheism. The Judeo-Christian faith dug in its heels on the temporal finitude of the past and the creation of the universe, despite the materialistic views that opposed it. And now science has verified this prediction. So this is one area of overlap where science can either verify or falsify religion or religious claims. And so I do think that while these are markedly different in their aims, nevertheless there is areas of overlap where science can verify or falsify religious claims, and also I would say where theology can actually aid science in dealing with metaphysical problems that science confronts, that science isn't itself equipped to answer.
The next question is the Big Bang scientifically proven to be the origin of the universe?
Well, that all depends on what you pack into that word proven. If you mean some sort of mathematical proof or certainty, of course not. But you see, that's the very nature of science. Sean Carroll, who is a contemporary cosmologist, put it very nicely. He says, science isn't in the business of proving things. What it does is it furnishes explanatory models for phenomena, which are then assessed in terms of their explanatory power, explanatory scope, plausibility, fruitfulness in their predictions, and so forth. And I would say that the Big Bang Theory is the most successful model that exists today with regard to the evidence. It explains very well all of the evidence that we have, and there doesn't seem to be any evidence on the other side. In that same conference I mentioned, at which Vilenkin spoke at Cambridge, he was interviewed for a popular science magazine, and in this interview he said a remarkable statement. He said, all the evidence we have says that the universe had a beginning. Now that's a striking statement. He doesn't say the evidence for a beginning outweighs the evidence against a beginning. No, he doesn't say that. He says all the evidence we have says that the universe has a beginning. There just isn't anything on the other side of the scale. So while the results of science are always provisional and susceptible to revision, nevertheless, I think that the person who believes in the beginning of the universe stands squarely and comfortably within the scientific mainstream today.
So we had a silly question, that's why people were laughing. But anyway, we'll deal with that later. But there's a question here about the people you've had discussions with.
Yes.
Have you ever had a discussion with Hawking? You mentioned you had a discussion with Hartle. If so, what was the result? If not, have you asked?
No, I haven't. I mean, you need to understand how seriously debilitated Hawking is with Lou Gehrig's disease. And so it's not possible for just anybody to sort of get an audience with him. So no, I never have. I've interacted with his work in print. And in one of his books, though he does not cite me, there are phrases that are almost lifted verbatim from things that I've written where he is responding to these. Now, I don't know that he is, in fact, responding, but I know Quentin Smith, an atheist friend of mine, philosopher at University of Western Michigan, said, Bill, have you seen this? And pointed this out to me, and it seemed to us that this did look as though he was engaging a little bit. So I haven't had any personal interaction with him. I've just simply tried to interact in print with his work.
you had interactions with Hartle. You mentioned that you may have.
Yes, now James
that's quite
Hartle,
interesting
yes,
too.
because
what
we
came out of that
lived in
discussion?
Santa Barbara. I taught at Westmont College for a year, and so I made an appointment with Hartle, went by his office at UCSB, and we sat down and had a very nice chat. I try regularly to meet with and converse with astrophysicists in order to make sure I'm not getting off course, because the danger of a philosopher working in the interface between philosophy of physics is you make mistakes in the area you're less familiar with, and so you need collaborators. And so I've had the opportunity to talk with people like Christopher Isham of Imperial College, James Hartle, Donald Page at the University of Alberta in Canada. When we were living in Brussels, I met with Robert Brout and François Englert, who since then have been awarded the Nobel Prize for their work in astrophysics. And I thought, wow, how exciting that I actually sat down with them in their office at the Free University in Brussels and ran questions about vacuum fluctuation models of the universe by these two men who later won the Nobel Prize. So I try to interact with astrophysicists and cosmologists on this material to make sure that what I'm saying is accurate.
The next question is, and it's going back to a question that we've sort of skirted around, and maybe we need to answer this.
Yeah, maybe
must
we do.
God be personal?
All right. Let me try to summarize briefly 3 arguments why I think that the cause of the universe must be personal. First reason would be causal explanations can be either of 2 types. It can be a scientific explanation in terms of laws and initial conditions, or it can be a personal explanation in terms of an agent and his volitions. So, for example, if I walk into the kitchen and see a kettle boiling, and I say to Jan, "Why is the kettle boiling?" She could say to me, "Because the heat of the flame is being conducted by the copper bottom of the kettle to the water, causing the molecules to vibrate more violently until they're thrown off in the form of steam." Or she could say to me, "I put it on to make a cup of tea. Would you like one?" One is a scientific explanation, the other is a personal explanation. Both of them are equally legitimate forms of causal explanation, and in some contexts, one would be utterly inappropriate when the other would be appropriate. Now, when it comes to a first physical state of the universe, there cannot be a scientific explanation of that in terms of initial conditions and natural laws, because it is the first physical state. There is nothing prior to it from which you could deduce it by natural laws based on prior conditions. So the only kind of causal explanation that's available will be an explanation in terms of an agent and his volitions, and that gives you a personal creator. Second reason, the cause of the universe, as we've seen, must be timeless and spaceless and changeless. Now, there are only, and immaterial, and therefore immaterial. Now, there are only 2 possible candidates that I can think of that could fit that sort of description. Either an abstract object, like a number, a mathematical entity, these are timeless, spaceless, immaterial, or else an unembodied mind or consciousness, a mind without a body. But there's the rub. Abstract objects don't stand in causal relations. That's definitive for what it is to be an abstract object. And therefore, things like the number 7, for example, have no causal effects upon anything, from which it follows, therefore, that the cause of the universe must be an unembodied mind or person. So that would be the second reason. The third reason is that it's the only way in which you can explain how to get an effect with a beginning from an eternal cause. If the cause is sufficient to produce its effect, then if the cause is always there and is permanent, then the effect should be always there as well. For example, if the cause of water's freezing is the temperature being below 0 degrees Celsius, then if the temperature were below 0 degrees from eternity past, it would be impossible for the water just to begin to freeze a finite time ago. Any water that was around would be frozen from eternity. If the cause is there, its effect must be there as well. So how do you get a cause which is permanent and eternal, and an effect like the universe, which only began to exist 14 billion years ago? The only answer to this conundrum, I think, is if the cause is a personal agent endowed with freedom of the will, who can therefore create a new effect spontaneously without any antecedent determining conditions. For example, a man sitting from eternity could freely will to stand up, and thus you would have an effect with the beginning arise from an eternal and permanent cause. So for those three reasons, I think we have very powerful grounds for thinking that this is not simply an uncaused first cause, but this is a personal being, a personal agent, which has chosen freely to bring the universe into existence.
Now, we're running out of time now, but there was one burning question. So I have to ask you this because it had 37 votes. Do you actually watch the Big Bang Theory TV show at all?
I've never watched it.
Well, you have a long flight on the plane tonight. Maybe you can check it out. Anyway, before I let you go, there are two things that I want to say. The first is that if you've been stimulated by this talk and you have more questions, there is a follow-up lecture called Big History that Dr. Andrew Locke is giving on the 31st of March in general education. So please look at the general education website and you can sign up for that and you can ask more questions and find out more. And secondly, we will have an event in 2 weeks' time. It is a Veritas Forum event, which is something that started in 1992, I think, at Harvard and has gone around many prestigious universities and is coming to Hong Kong for the first time. So please come to this. It's related to science again. Professor Troy Van Hohis is coming. He is an MIT professor of chemistry, and he's going to speak on scientific progress and the question of suffering and hope. So please come to that event. And finally, I would like us all to thank Professor Craig. Please give him a very big thank you.